If the base angles of a triangle are given as 22.5 degrees and 112.5 degrees, then show that the base is twice the height. Okay, let us begin. First, let's try to understand the problem graphically. So here we have the triangle ABC. So the base angles are given. So let's say angle B, that's 112.5. So half means that's simply 0.5. So 112.5 degrees, that's the angle measure of B. And the angle measure of C, we're going to consider it as 22.5 degrees. Okay, so we need to show that CB, that is the base of the triangle ABC. We need to show that the base is twice the height. So here AD is going to be the altitude or the height of the triangle ABC. Okay, let us begin. So here what we'll do, we are going to name the sides of the triangle ABC. We'll start with the angle A. The angle A has got the side BC opposite to it. We're going to denote it by the letter A in lowercase. Okay, then we have AB. AB is the side that is opposite to angle C. So we're going to denote that length by C. And then the third side AC, that is the side opposite to angle B. So we're going to denote it by B in lowercase. And AD is going to be the height or the altitude of the triangle. Let's denote it by the letter H in lowercase. Okay. So here, what we'll do, let's try to figure out the angle measure of ABD. So for this, we're going to consider the right angle triangle ADB, which is right angled at D. So let's try to figure out the value of angle ABD. So here we know that ABD plus ABC, that is a supplementary angle. That means the angle adds up to 180 degrees, which means that angle ABD is simply going to be equals to 180 degrees minus the angle measure of ABC. Now ABC, that's already given to us 112.5 degrees. So let's substitute this here. So we have 180 degrees minus 112.5 degrees, and that should give us the angle measure of ABD, which comes out to be 67.5 degrees. So we have the angle measure of ABD. Now if we take sine of the angle, so now if we take sine of the angle ABD, so this is simply going to be the ratio of, we know the sine is the opposite, which is the A value H, divided by the hypotenuse. So the hypotenuse is denoted by C. So in other words, what we have here is sine of angle 67.5 degrees. So that's going to be equals to H over C. Okay, so let's isolate C from here. So C is going to be equals to H over sine 67.5 degrees. Okay, we're going to further simplify 67.5 degrees. So whenever we have sine of 90 degrees minus theta, we know that that corresponds to cosine of the angle theta. In other words, these are allied angles. So here what we have sine of 67.5 degrees. But we can also rewrite it as sine of 90 minus 22.5 degrees. So 90 minus 22.5 is simply 67.5. But we know the sine of 90 minus some angle theta, that is going to give us cosine of angle theta. So we have cosine of 22.5 degrees, which means that sine 67.5 degrees, that's the same as cosine 22.5 degrees. In other words, we can replace the sine 67.5 with cosine of 22.5. C, side measure of C is going to be H, the altitude, divided by cosine of angle 22.5 degrees. We're going to keep this aside for the time being. Okay, now again let's go back to our triangle. So here we have the triangle ABC. Now in this triangle we're going to apply the law of sines. The law of sines states that if we know the three sides of the triangle as well as the angle measure, then the ratio of the side A to that of sine of the angle opposite to that side A, so that's going to be angle A, that's going to be equals to B over sine B equals to C over sine C. We're going to take the help of this law of sine. So here what we'll do, we're going to consider the triangle ABC and let's apply the law of sines here. Now the law of sines, for this what we'll do, we're only going to take two ratios at a time. Now here we're going to consider the ratio A over sine A and we're going to equate it to C over sine C. Now, this is a very specific way of choosing the ratio, because we are choosing c over sine j because we have already computed the value of c. So it's in terms of the altitude, that's h over cosine of 22.5 degrees. So we can take it and replace it in place of c here. And then we are considering the ratio a over sine a, because in the problem we needed to show that the base is twice that of the altitude. So that means we need to have the side a here. So that's why we're choosing a over sine a. Now we need to find out the angle measure of A. Okay, so here clearly in triangle, so here we can again use the triangle ABC. What is the angle measure of A? Angle measure of A, that is simply going to be 180 degrees minus B plus C, because we know that in the triangle ABC, the sum of the three angles add up to 180 degrees. So we have 180 degrees minus the angle B, that's 112.5 degrees, added to angle C, so that's 22.5 degrees. So when we compute this, we're going to get 45 degrees. So that means the angle measure of A, that is 45 degrees. So here we have A over sine 45 degrees. That is going to be equals to C. So here C can be replaced with H over cosine of 22.5 degrees. Multiplied to, we have sine of angle C. So sine C, that means we have sine of 22.5 degrees. Okay, so let's further simplify. Now here we have A over sine 45 degree. We can have, so let's keep it as sine 45 degrees. This is going to be equals to, now here what we'll do, we're going to do a manipulation here. We're going to multiply the right hand side of the expression, both the numerator and the denominator, with 2. The reason why we're doing this, because in the denominator what we have is 2 times cosine of an angle theta multiplied to sine of an angle theta. Now there's an identity, so whenever we have 2 times sine of angle theta times cosine of angle theta, that's simply equals to sine of angle 2 theta, which means we can replace our denominator with sine of 2 times the angle theta. So what is 2 times 22.5 degrees? So that's simply 45 degrees. So we have sine 45 in the denominator, which gives us A equals to 2 times H, and that proves our problem. What does it mean? So here we have obtained that the base, which is denoted by A in our diagram, so the base A, so that comes out to be twice that of the height of the triangle, or the altitude of the triangle. So we can say that thus the base is twice the height of the triangle, hence proved.